Okay, so we're going to do a little bit of extra proof practice, but the beginning problems here, the first 6, numbers 9 through 14, this one is just asking us to determine if we could prove them congruent using side angle side. Because when we covered this chapter, that was the first shortcut we had learned. So if I zoom on in here to number 9, it wants me to see if I can prove that triangle ABD here is congruent to triangle CDB. So, and it wants us to see if we could use side angle side. So let's go ahead and let's sort of look and see what we have identified here. I've got a side that's marked as congruent, which matches with this one, has the same marking. And then I also have an angle here. Now I can also bring in my reflexive side here that's in the middle, if I were writing a proof, and say that BD is congruent to BD. Now remember, in order to use side angle side, it must be the included angle. So in this particular picture, that A that I have with a capital A in blue marked is not the included angle. So this one you could not use side angle side. In order to do side angle side, we would have needed this angle to be marked as congruent to this one, because that would have been the angle that was formed by the two congruent side that were marked. So this one, there's not enough information. Then for number 10, this one we could, because we have this side that matches. We have the right angle that is marked, and all right angles are congruent. And then we also have this last side over here matching with this one. So it is the included angle, or the angle that's formed by the two congruent sides. So this one would have been yes. For number 11, we can add in a congruency mark on my reflexive side. So far I have this side matching with this one. I could also say that this angle over here is also 90 degrees because this is a linear pair, and I could just do 180 minus 90 and get that that side is 90. And then I could also mark my reflexive side. Now, this side matches with itself, but notice the angle that is marked here as being congruent is not the included angle for both triangles. So the two triangles I'm asking you to try to prove is this one here to this one here. Now, in the blue triangle, this one is the included angle. It's formed by the two congruent sides. However, this angle here, this right angle, which is supposed to match, is not the included angle. The included angle in the red triangle would have been up here. So this is not enough information. The two angles are not congruent. Yes?
Could you also say...
Number 12. They're asking me to prove that this triangle over here on the side, QRV, is congruent to TSU, to this one over here. So for this one, if I take a look at it, let's see. So we've got a side. Oops, let me not do here. So a side matches here, and then this side. And then notice the angle is not the included angle. So this one would be no based on that given. If they were to have changed the given and stated that Q was congruent to T, then we could have proven them congruent. But because the blue angle A was not the angle formed by the two congruent sides pairs, then this is a no. Then number 14 or 13. This one, I can match this side with this side, this angle with this angle, and then I can also label the reflexive side, and now I can show that from side, the included angle to the side is congruent to this one here. So this one is a yes. It is the included angle. And then 14, again, these arrows are not congruency marks. They're parallel marks. So what I can do here is I can show that these are parallel. And then this is my transversal, making this angle congruent to this one. So I've got an angle that's marked. I've got a side that's marked. And then I can add in my reflexive side. However, the angle that is marked is not the included angle. So if I get rid of these parallels, you can see that the side that's marked as congruent, the angle that would have needed to be marked for the included angle would have been this one up here, and then this one down here, because it would have been the angle formed by the two congruent sides. So this one is no as well. So let's try the proofs now. So when I give you the proof to write, you will be able to write a proof. That's not going to be the issue. But if you get a question that states, can you prove it, yes or no, then you can actually answer a question like that. So let's set up our statements and our reasons. So here it says, given that PQ bisects angle SPT and that SP is congruent to TP. And that's our given. Now notice the picture was already labeled for us. Generally, the picture won't be labeled for you. So our picture's labeled. We need to state these congruencies in our proof. Now the SP congruent to TP is already there, but we have to state that those angles that are marked that are congruent because of the bisector, we need to state that in our proof. So what I need to do as my next statement is state that angle SPQ is congruent to angle TPQ. And the reason why I can state this is definition of an angle bisector. And that's these two angles that are marked right here. That's this one, and then this is this one. My next piece that I can state, and you could have stated this first, and I'm going to state the reflexive side, that PQ is congruent to PQ. And that's reflexive. Now, you could have put this statement as statement 2, and then the one for the definition of the angle bisector is step 3. You could flip-flop those two. And now notice in my picture, I've got a side and a side that match. I've got an angle and an angle that match. And then I've got the reflexive side. So it is the included angle because it is the angle formed by the congruent sides. So now my next statement is going to be what I was asked to prove, that SPQ is congruent to TPQ. And my reason is side angle side. All right, so here we go. Number 1, AB is congruent to CD, and AB is also parallel to CD. So that was given. And again, it is labeled in the picture for us. So remember, when I have parallel lines, I can treat this diagonal as a transversal, which now makes angle 1 congruent to angle 2 because these are alternate interior angles. So that could be my next statement. It was nice that they labeled it with a 1 and a 2. Otherwise, I would have had to label it with 3 letters. I would have had to call it BAC, congruent to DCA, or in reverse. So instead, I'm just going to say angle 1, congruent to angle 2. And the reason here is the alternate interior angles theorem. Now remember, when you're trying to prove lines parallel, it's the alternate interior angles converse. My next statement is going to be this obvious, the reflexive side. So I can state that AC is congruent to AC, and it's reflexive. And again, you could have written this as step 2, and then the alternate interior as step 3. You could have flipped it. And now I've got enough information labeled in my picture. I've got this side that matches with this one. I've got this angle that's marked and it's congruent to this one. And then now the reflexive side in the middle. So again, the angle formed is the included angle. So now I can state what I was trying to prove, that triangle ABC is congruent to triangle CDA, and my reason is side angle side. Yes. So for number 17, again, I'm going to set up my statements and reasons. So number 1, I'm going to put in my given that C is the midpoint of AE and BD. Now, notice the pictures labeled for us. Again, on the midterm, I will not add the congruency marks to the picture because this could be confusing because you're thinking, oh, the picture is already labeled, that was given to me. Again, I would just state that it's the midpoint. Now you have to add into your proof statements what a midpoint does. And it's those congruency marks there. So we need to now state, so I'm going to state what a midpoint does. So I'm going to go ahead and state that AC is congruent to EC and that BC is congruent to DC. And you have to. Again, on the midterm, I won't label the picture. So you have to say what a midpoint does, and it splits the segment into 2 congruent pieces. So this is definition of a midpoint. Next, this is my classic bow tie. I'm going to bring in my vertical angles. What this midpoint has done, this midpoint C, it's taken AE here and it breaks it apart and makes 2 congruent pieces. And that's what I just stated here, that AC was congruent to EC. And then I did the same thing for the other segment here that C was the midpoint for. I stated that BC was congruent to DC. So you have to state that. And that's definition of a midpoint. Good? Yeah. All right. Next, I'm going to bring in the vertical angles that are here. This one right here is congruent to this one right here. I can't just call it angle C. I have to name it with 3 letters. Again, I can't name this just angle C is congruent to angle C. I need to name it with 3 letters. So I'm going to state that angle ACB is congruent to angle ECD. Again, C must be the middle letter here. And this is my vertical angles congruence theorem. And you can abbreviate that with VAT. Now, if you would have rather said that as step 2, and then the definition of the midpoint statement as step 3, you could flip-flop those 2. Then next, number 4, we're going to state that triangle ABC is congruent to triangle EDC, and my reason is side angle side. Because again, I've got this side congruent to this side congruent to this one, and then I've got the vertical angles. And again, it is the included angle that is marked with the congruency. So I can use side angle side here. So number 18, again, I'm going to set up my statements and reasons. So again, state the given that PT is congruent to RT and QT is congruent to ST. Notice this looks very similar to the other picture, but this time they weren't giving us that T was the midpoint. They actually gave us that the segments were congruent. So for this one, I don't need to put anything about T being a midpoint. All I need to do is add in my vertical angles and I'm done. So PQT, so the two triangles they're asking me to prove congruent are PQT, the top one, and then the bottom one, the RST, and then I can show the vertical angles that are here. I also have another pair over on this side, but I'm not going to state those because that's not the triangle I was asked to prove congruent. So my next statement is going to be those vertical angles that I just marked, which are going to be the PTQ is congruent to angle RTS, and this is the vertical angles congruence theorem. And then now triangle PQT is congruent to triangle RST. And again, shortcut is side angle side. Because again, you've got a side, an angle and an angle, and then a side and a side. And again, it is the included angle. So the next one, there's just two. So again, let's set up your statements and reasons. We'll state our given. LM is congruent to JK, and MJ is congruent to KL, and this is given. My next thing I need to do is, so far I have a side that matches with this side, and then I got another, oh, that's not an angle, that's a side. And then now I could also bring in my reflexive side, and now I have enough information to prove them congruent by side, side, side. So I'm going to bring in the reflexive and say that JL is congruent to JL. You could also call it LJ, doesn't matter. This is reflexive. And then now my next statement is that triangle LMJ is congruent to triangle JKL. And the reason now is side, side, side. Pretty good there. Okay, let's try the next one. This one's a little bit more complicated. You will not have anything this complicated as number 16. I know it's fuzzy. You should be able to see the proof on your copy. All right, but let's set up statements and reasons. So again, number one, all this given. WX congruent to VZ. WY congruent to VY. YZ congruent to YX, and it's given. And then what I'm going to do is the two triangles they're asking me to prove congruent are the VWX, which is this one right here, and I'm going to recopy that one over here and pull it apart. And then this other one that's down here. write it this way. And you can see that the WV is the same. So now let me add in the congruency marks that were labeled. So this one had 3, and then here, and then now what they did though, they had another point here, Y. And then this piece, the VY and the WY were congruent, and then this piece. So this is where I'm going to be bringing in my segment addition postulate into this proof. So number 2, we're going to bring in, I'm going to bring in the obvious first. I'm going to say that VW here is congruent to VW by reflexive. So VW or WV, it doesn't matter. It's congruent to itself, reflexive. So notice so far I have this side and this side congruent, and then this side and this side. In order to show that this side here is congruent to this side here, I'm going to have to do a segment addition postulate. So I'm going to show first how Vx is made up of. So I'm going to show that Vx is made up of adding Vy plus Yx. And then the other one, the Wz, is made up of adding the little piece of Wy plus Yz. And this is segment addition postulate. I would be familiar with this postulate. You may need it for maybe the other proof. So now here what we're going to do is I'm going to do a substitution to show that these two things are equal. So I'm going to actually work with this one right here. And if you notice up here where Vy is, it's equal to Wy. So now my next statement is going to be Vx, and I'm replacing Vy with Wy. And then I'm also going to replace this one, Yx, or Xy. Let me do a different color. This one. Notice right up here in my given, it was equal to Yz. And that's what I'm going to replace. I'm going to put Yz here. Oops. And then notice that right up above it, these two statements now look the same. So what I just did to come up with statement 4 was substitution, not transitive. Now my next statement, since these two things are the same, I can now state that Wz is equal to Vx. And now this could either be transitive or substitution. And now that I have the two green ones as congruent, I now can say that the two triangles are congruent by side, side, side. So my next statement, and again, I would have just kept this as a congruence throughout, and then you don't have to put in that extra step of definition of congruent segments. So VWX is congruent to WVZ, and this would have been side, side, side. Okay, so we're going to come on in here, and I'm going to do number 17 with you. Now, this was actually all of these pages here, and I know you can't see the picture here, but when I make the video, it will be clear. I found all of these. These are just screenshots from your e-textbook. So you can always look for additional problems, but I tried to pull as many proofs as I could. So let me go ahead and set up my statement and reason columns here. Now on the midterm, it's not going to tell you you're using a specific shortcut. You need to memorize those, which one you're going to use. And there's 5 of them. So you're either going to get a side-side-side proof, a side-angle-side, a hypotenuse leg, angle-side-angle, or an angle-angle-side. So this is why I'm trying to do as many proofs that I can with you so you can see all of the different types. So for the first one, I'm going to state my given. Don't forget about that. It's worth points. So M is the midpoint of NL. And then we're also told that NL is perpendicular to NQ, and that NL is also perpendicular to MP, and that QM is parallel to PL. All of this was given to you. And it's also, the parallel is indicated in the picture. However, and you can see the perpendicular has been indicated with the right angle. Now, on the midterm, I probably will not have the picture labeled for you. You would have to take your given and label your picture. Okay, so for now, what I need to do is somehow find enough information to prove that these 2 triangles are congruent. And here, it was a hint. They said to use angle side angle. So just by drawing in the little square that shows that angle N and M are right angles, I actually have to name it and show that they're congruent. And then I could just say all right angles are congruent, or the right angles congruence theorem. So I could say that angle QNM is congruent to angle PML, and I can state here the reason is I could either say all right angles are congruent, or I could call it the right angles congruence theorem. The next thing I'm going to do is you need to realize that you have parallel lines here. And then what I can do is show that I've got a pair of corresponding angles that are congruent. So I could state that this angle here, because this would be my transversal, so I could show that this angle here is corresponding to this one. And I need to name it with 3 letters. So I'm going to state that angle QMN is congruent to PLM because of the corresponding angles theorem. And then next thing I can do is use the given that M was the midpoint. So I can go here and show what a midpoint does. It splits this segment into 2 congruent pieces. So I can state that NM is congruent to ML by definition of a midpoint. Now that I have the right angle and these corresponding angles and the included side, I can prove that these 2 triangles are congruent by angle side angle. So then my last statement is triangle NQM is congruent to triangle MPL, and this reason is angle side angle. I can see I already went into number 18. I'll go to the other side and do 18. Now, some of these proofs are going to get, like the next one might be a little bit long. You won't have anything as long as number 18, but it's just good proof practice to see how the logic flows. So if I come over here for 18, statements and reasons. Again, I'm going to state my given that AJ is congruent to KC, and that angle BJK is congruent to angle BKJ, and then angle A is congruent to angle C, and that's given. Okay, so the next thing what I can do here is, and this is already all labeled in my picture. So the next thing I'm going to do is show, because the two triangles, let me highlight the two triangles. I know it's kind of fuzzy for you, but the two triangles that we're asked to prove are congruent are this one right here. Let me highlight it here. And then this one over here, this CBJ. So they sort of overlap, and you're going to see how they share a part of that triangle. So what I'm going to do is show how this segment here, the AK, what it's made up of adding AJ plus JK. And then I'm also going to do the same thing for the JC. Show that it's made up of adding JK and KC. And then if you notice, they both share this piece. And this is where I could use a substitution here. So let's go ahead and first use the segment addition postulate. So again, I'm going to say that JC is made up of adding JK plus KC. And then AK is made up of AJ plus JK. And this is your segment addition postulate. Next, what I'm going to do is I'm going to work with this statement right here. And I'm going to do a substitution. And what I'm going to do is, since AJ up here equals KC, I'm going to take out AJ and I'm going to put in KC. So I'm going to, my next statement, and the reason's going to be substitution. I'm going to now say that AK, instead of being equal to AJ plus JK, I'm going to say it's equal to KC plus JK. And this is a substitution. And now if you look at it, these two are exactly the same. This part of it, it's just flipped around. So if you wanted to flip it around and say commutative property, you could, but I'm just going to jump right to JC is congruent. And you could have left as all of these as congruent, so you don't have to put in that extra step of definition of congruent segments. And then here would be transitive, or in this case, you could use substitution. In step 3, you can't say transitive there. It has to only be substitution. And now I can go right to my triangle congruence, because now I have this side of the red one congruent to this side of the blue one. And then I also have the angle marked as congruent, as well as the AJ. So then I have now enough information on my picture to show that these two are congruent. So now I can state that, let me see, I need another one here. I need this angle. Okay, so then now what we're going to say is, let's see, where was I? Here. That triangle ABK is congruent to triangle CBJ. And we got angle side angle. Then 19. It's the picture right here. So again, statements and reasons. So for 19, we are given that VW is congruent to UW, and angle X is congruent to angle Z, and that's our given. And let's see, did they mark everything? Yes, they did. Okay, so the two triangles, and again, I know it's fuzzy, that you're asked to prove congruent are XWV, so this one right here, maybe I'll do it in highlight. This one compared to ZWU, which is this one. So let's go see what we got. So far I've got an angle marked as congruent and then part of a side. So here what I can do is we can see that it's got an angle W. That's the same for both. It's the same angle W in both. And then from there, we can show that the triangles are congruent, this time by angle side. So let's go ahead here. And sometimes it helps if you pull them apart. You can maybe see it a little bit better. So you could redraw them if that helps you. So the next thing I'm going to state is that angle W is congruent to angle W, and it's reflexive. And then now, since I had two angles marked, I have angle W to angle W, and then I have X to Z, and then I also have that side that was given to me as congruent. So now I can say that XWV is congruent to triangle ZWU, and my reason is angle side. Because two of the things were given to me, a side and an angle here, and then I just needed to provide the other one. And again, angle side there. Let's try the next one, number 20. So this is the picture here. Again, I know it's kind of fuzzy for you guys. Let's see what we can do here. Statements and reasons. So again, number one, just restate your given that angle NKM is congruent to angle LMK, and angle L is congruent to angle N. And this is given. And again, it's already labeled in your picture. So again, we're going to try to prove this using angle side. So already we have two angles. We just have to come up with the side that's congruent. And the side that's congruent is the one that they share. It's this KM at the bottom. Because again, the two triangles we're trying to prove congruent are the NMK, this one right here, congruent to this one right here. And notice this side here is what they share, so it's reflexive. So my next statement, nice and short and sweet, it's just going to be that KM or MK, doesn't matter which way you say it, is congruent to KM, reflexive. And now we have two angles and a side, and it's not the included side. So that's why it's AAS and not ASA. So triangle NMK is congruent to triangle LKM, and we're done. Now the other question that's on here is number 26. They just wanted to know which of the following congruent statements are true, and then select all that apply. The only one that's true here is C, because the two triangles that are congruent are going to be the TVS, this one right here, is congruent to VWU. So those would be the two congruent triangles in this picture, and what you would be using is angle side angle. And then the next page says to prove this triangle congruent by using side angle side. This was actually just a screenshot from the textbook. It was from section 5.3, and it was actually an explanation. It was an example, but just to show you how you would work it out. Statements and reasons. Number one, AC congruent to EC, and BC congruent to DC, and this is given. It's already labeled for you. So now the only thing I need to add in here are my vertical angles on either side of this bow tie. And again, I need to name it with 3 letters. So I'm going to call it angle ACB congruent to angle ECD. And this is my vertical angles congruence theorem. And now I have enough information to prove them congruent by side angle side. So triangle ABC congruent to triangle EDC. And the reason would be side angle side. Then for number 8, they want to know, is there enough information to prove the 2 triangles are congruent using side angle side? Well, the only other thing that's not marked here that I could add in is the reflexive side. But notice this angle W here is not the included angle. So this one does not have enough information. It is not the included angle marked with the congruence. And then this one, these are parallel marks, not congruent marks. So what we could add in here for number 9 is, let's take a look here. This is congruent. And then if I realize that these guys are parallel, then I have a pair of alternate interior angles here. And then I could also add in my reflexive side. And again, notice I do not have the included angle here. So this would be not enough information to prove side angle side again. Pretty good so far. All right, let's see what else we got. All right, so for here, isosceles and equilateral. So if you get questions where they ask you to fill in things, here, QP, if QP is congruent to QR, notice this is now a little isosceles triangle here. Then that would tell you that the 2 base angles are congruent. So here you could call this one angle P. So you could say angle P here. But this one over here, you'd have to name it with 3 letters. You could either name it PRQ or QRP, either way. So be able to pull things out like this. Number 11, it says if TRV, this angle here, is congruent to TVR, this one, then what can you conclude? We can conclude that this is a little isosceles triangle here, and the sides across from those congruent base angles would also be congruent. So we could say that TR is congruent to TV. And then the next one, if RQ, let me switch the color here. We'll change it to blue. So here for number 12, RQ, if it's congruent to RS, again, notice we got a little isosceles triangle here. So then that tells me the base angles down here are going to be congruent. And again, we're going to need to name them with 3 letters. So here I could say that this angle right here is going to be angle RQS, is congruent to this one over here, and this will be RSQ. And then number 13, yes. Yes. And then next thing, again, if we go ahead and, let me see if I can erase some of this. It's gotten too busy. So now for number 13, it says that SRV, this one, nope, not that one, SRV, this side, and it's congruent to SVR, this one, again, another isosceles triangle, then we can see that this side is congruent to this side. So we would say SR or RS, either way, congruent to SV. And then here, same idea. There was a question similar to this on the test. Remember, if this is equilateral, all sides are this. If it's equiangular, it's also equilateral. And then if these two base angles are congruent, then I know the sides are congruent. So then here what I can do is the 26 is congruent to the 5y minus 1 or plus 1. Set this up. Divide by 5, and y equals 5. And then over here for the 8x, if you realize that this is an equiangular, then that means all of these are 60. And if this is a straight line, I know the 8x side is going to be 120. So to find x, I'm going to set 8x equal to 120. I'm going to divide 120 by 8. And I get 15. So that would be that one. And then one last page. Again, a few more proofs. So this time they want us to use side, side, side. But again, on the midterm, I'm not going to tell you which shortcut to use. You're going to need to figure that out. So statement, start by the given. Don't forget it. It's worth points. AB congruent to CD. And it's given. Next thing we need to do, if we want side, 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 show the reflexive. So next statement would be that BD is congruent to BD. Reflexive. And then lastly, now that I've got three sides that are marked, I can say that triangle ABD is congruent to triangle CDB. And the reason is side, side, side. And then for 15, it wants you to determine, is there enough information to prove that triangle LMP is congruent to NMP using side, side, side? Well, the only other thing we can pull in here is the reflexive. I do not have any markings on this one or this one, so no, there is not enough information. I would need all three sides with markings. And then number 16 says to decide if there's enough information to prove that these two triangles are congruent using hypotenuse leg. Well, I've got a right angle. I've got legs that are marked as congruent, and then I can put in the hypotenuse. So here I could do the reflexive side, and yes, I could use hypotenuse leg here. And then the last one, again, state your given. AB is congruent to DE, and angle ABC is congruent to angle DEC, and it's already labeled in the picture. So this is your given. And let's see what we need. It says to either use angle side angle or angle angle side. So I've got my bow tie here, so I can add in a congruency mark for the vertical angles. So my next statement could be that angle ACB is congruent to angle DCE. What's important here is that the middle letter is a C. Vertical angles congruence. And now I have enough information to prove the two triangles are congruent using angle, because I got an angle here at the vertical. Then I got another angle here. And then I've got my side. So using angle, angle, side, I can prove the two triangles are congruent. ABC is congruent to triangle DEC. So that is it for the notes on the proof practice.